factoring sort as a topic, and we have a sample which says, without using mathematical tables or calculator, evaluate leaving your answer in sort. Yet we have sine 45 degree plus cos 60 degree odd over tan 30 degree. And we see this question now that he has not given in the sort form. What we need to do is that we need to derive the trigonometry ratio of this sine 45 and cos 60 and tan 30. Right. So let's proceed. We have our solution. Right. We have sine 45 degree plus cos 60 degree all over tan 30 degree. Right. So now let's derive our trigonometry ratio. Let's draw a square as a unit. So it'll be 1 unit. We can label it, call this side A. We call this side B, C, D. Now let's draw a diagonal from B to D. Right. So from here now, here will become 45 degree. This side as well will be 45 degree. Here is 90 degree. Right. So now we can bring out our angle ABD out. Right. This is our angle ABD. This side is A. Here is B. Here is C. We have 1 as a unit here. So here we are looking for this side, which what we are looking for. Now we are going to apply what we call Pythagorean theorem. Right. So Pythagorean theorem says that the hypotenuse, which is BC, the square of hypotenuse, will be equal of the square of the sum of the other side. We have AC, line A, C square plus line A, B square. Right. So from here, substitute the value there. Line B, C, that is what we are looking for, equal to 1. Here is line AC is 1 square plus line AB is 1 square. Cosine 1 square will be the same as 1. 1 square the same as 1. And 1 plus 1, that is 2. Both sides. We have BC. Line BC will be equal to square root of 2. So our value here now, hypotenuse will be square root of 2. Now, if for sine 45, we have sine 45 degree will be equal to, now this one down, we have for easy to know which one is opposite, which one is adjacent or hypotenuse. Now, for what these SOHCAHTOA that are written down, that X here, we use it as a sign, right? And O, it will be the opposite, and H will be the hypotenuse, right? Now, see that the opposite, we have our 45 degree here, right? And this side too is 45 degree. Now, what is the opposite to this angle? Here is the opposite to this angle, while here is the opposite to this angle, right? So from here now, we have sine 45, which is our sine is opposite over hypotenuse. That is it here, opposite over hypotenuse. That is the easier way for you to remember this formula. So from here now, what does sine 45? Now, the sine 45 will be equal to opposite, which is the opposite, is 1, 1. Any angle you pick, The 1 is the opposite. We have your 1 here. And what is the hypotenuse, which is our root 2? We have square root of 2. Therefore, our sine 45 now degree equal to 1 over square root of 2. This is the trigonometric ratio of 45 degree, right? So now we are looking for cos 60 degree and tan 30 degree. If you look at this angle, you see that there's nowhere that we can see sine cos 60. There's 60 or 30 degree here. No. So we need to draw equilateral triangle. We call this equilateral triangle. From there we can, which is the opposite, they are all equal. Now, the three sides are all equal. Equilateral triangle, all the angle will be 60 degree. So let's draw another angle here. So here is 60 degree. Here also is 60 degree. The three sides, they are 60 degree. Now, here will be 2 units, 2 units, 2 units, because they are all equal sides. So from here now, we label this side as our A, and this side as B, this side as C. Now, let's draw a perpendicular line to bisect AC from B. This line from B to cut line AC to divide it into 2 equal parts. Then this side will be 1, here will be 1, right? So from here now, we can call this side Q. Right. Now let's bring out our angle ABQ. So it will look like this. We have our A here, we have our B this side, and we have our Q here, right? So from here now, here is 1, here is 2. So we are looking for this side, right? You remember the Pythagorean theorem that we applied here. Let's apply the same thing here. So from here now, know that this side is 60 degree. Here is 60 degree. When you divide 60 degree by 2, it will give you 30 degree. So we have our 30 degree here, right? So from here now, we apply to look for the value of this way. So we apply the Pythagorean theorem first. So we have line A, B square will equal to line B, Q square plus line A, B square, right? So from here now, we have AB square plus AQ, right? Here will be AQ. So from here, we have our AB square, which is our AB is 2. I have 2 square be equal to BQ. We have BQ, right? Which is what we don't know. We are looking for BQ square plus AQ. AQ is 1. We have AQ as 1 square. Now, and 2 raised to power 2 give you 4. Be equal to BQ square plus 1 raised to power 1, which is 1. Now, let's collect the like time. Bring this one this side. Bring this one here. So it will be minus. So now we have our BQ square be equal to 4 minus 1, which is we have 4 minus 1. 4 minus 1, which is equal to 3. Both sides we have BQ will be equal to square root of 3. Right. So here will now be our square root of 3. right? So now let's use our cos 60 now. Cos 60 will be 60 degree will be equal to now cos now. You remember that. Let's write it back again. We have, so from here now, this is SOHCAHTOA. So we have our cos, which is cos, right, is adjacent over our hypotenuse. Now we have our adjacent. Which one is our adjacent here? This 60 degree. Now, one is the adjacent to the 60 degree, and this side, which is square root of 3, is the opposite to this. Angle 30 now, here is the opposite. 1 is the opposite of this angle 30, right? Why the adjacent to it is this side, which is square root of 3. Now, we have cos 60 now. So our cos 60 say adjacent over hypotenuse, right? Our adjacent is 1, which is adjacent over hypotenuse, right? So what's the adjacent now? The adjacent to this angle 60 is 1 over hypotenuse, which is 2. That is 2. This is the hypotenuse. AB is the hypotenuse, which is 2. Now, cos 60 now is 1 over 2. Now, we have our sine 45 degree to be equal to 1 over square root of 2. Cos 60 degree will be equal to 1 over 2. Right, now we are looking for tan 30 degree, and here we have our tan 30 degree. Tan 30 degree is opposite all over adjacent. Opposite over adjacent, which is opposite over adjacent. That's 30 degree. Opposite over adjacent. So which one is the opposite now among this angle? You know, I told you that one is opposite to this 30 is the opposite, which is 1, and what is the adjacent to this angle? That is square root of 3. Now we have our tan 30 will be equal to 1 over square root of 3. So we derive the trigonometric ratio of the angle 45, angle cos 60, and the tan 30. Now let's substitute this value into it now. Now the question that given, our question now is sine 45 degree plus cos 60 degree over tan 30 degree, right? So, and we have our sine 45 degree as 1 over square root of 2 plus cos 60, which is 1 over 2, all over tan 30 is 1 over square root of 3. So the question now becomes this way in trigonometric ratio. So now let's apply rule of third now. Now, if you want to apply the rule of third, we consider nominator. This very nominator, call this nominator. This is the nominator. Why this one now is denominator, right? Let's consider it first. So the first things to do is that we look for the LCM of these two numbers. So we don't know, let's multiply them together to get our LCM, right? So from here now, the LCM of the two, it will be root 2, right? That is the LCL. So you know we have our 1 over square root of 3 here. So we are dealing with the denominator first, as I said earlier. So from here now, we have root 2. If we divide 2 root 2 by 2, it remains 2. So 2 multiplying the 1. Multiplying 1, we have 2, right? Now, we come to this side. 2 root 2 divided by this 2, to remain root 2 left, right? Multiplying by 1, we now have root 2, right? So from here now, we have root 2 plus square root of 2 divided by 2 root 2 divided by 1 over square root of 3. So just rewrite it, they're still the same thing. So from here, let rationalize this. This for the first one, the nominator, we are still dealing with the nominator, right? And nominator, this nominator now have denominator. I want you to understand that this nominator has what denominator. This very value here, you have nominator and you have denominator. So we are still dealing with it first. So from here now, we have now, let's rationalize this. We have 2 plus square root of 2 over 2 root 2 multiply by 2 root 2 divide by 2 root 2. Now, when you divide this one, 2 root 2 divided by 2 root 2 is the same thing like as is, it will be equal to 1. So just like we are not doing anything right now. So from here now, we have our 1 over square root of 3, right? So we have here now, as when we rationalize this, let's use this to multiply this, right? So from here we have 2 root 2 multiplying 2 plus root 2. This will multiply the number square of root 2 multiplying 2 root 2, and everything will be equal, will be over 1 over square root of 3. Now I want to explain something here. Here now will be equal to 2. 2 root 2 times root 2 times 2. That has been 2 times 2. We have 4 root 2, right, plus 2 root 2 times square root of 2. Now we have our 2 here. So square root times square root of 2. Let me explain that here. We have, if we have root 2 times root 2. Now this is the same thing as 2 raised to power half times 2 raised to power half, right? And 2 raised to power half times 2 raised to power half. You know the law of indices. You pick one of the two, you have their power, right? 1 over 2 plus 1 over 2. 1 over 2, which is your 2. 1 over 2 plus 1 over 2 is 1, which is 2 raised to power 1, the same thing as 2. So that is it. Now, we now come here now. 2 root 2 2 root 2 multiplying by 2 root 2. So we have the 2 times 2 here, right? Over the same thing here. 2 times 2, we have 4. 2 times 2, we have 4. And square root of 2 times square root of 2, we have here as 2. So everything now will be 1 over square root of 3, right? So now let's come here now. So we have this now. Here will be equal to 4 root 2 plus 2 times 2, that is 4, right? Over 4 times, this 4 times 2 will become 8 over 1 over square root of 3, right? So from here, if you look at this one here, this very one here, we see that 4 is common in this numerator. No, let's factor that out. 4 is common, is our 4, which is root 2 plus 1, right? So when you open this value, when you open this bracket, you have this value here, the same thing, over 8, everything over 1 over square root of 3. Now we can see that 4 can goes here, 1, 4 can goes here, 2, right? So our value that remain now is square root of 2 plus 1 over 8, 2, right? And everything over 1 over square root of 3. And this can now become, here will now be equal to, from here now we have our root 2 plus 1 over 2 divided by 1 over square root of 3, right? Now we know that if this one change to positive, to multiplication sign, the here we now reverse to what? Reverse, which is numerator. Numerator will come to denominator, while denominator will become a numerator, right? We have our root 2 here plus 1 over 2 times, now change this, now we have our numerator, we have your denominator here 3, and we have your numerator here, right? So let's multiply this together. We now have here the square root of here times the square root of 2, square root of, it is 2 times 3 for easy understanding, plus root 3, everything will be equal to over 2, right? So from here now we have square root of 2 times this, 2 times 2 times 3 is 6 plus root 3 over 2. This is the answer in short form.